As Elon has made very clear in recent earnings calls, in their effort to mass produce their new 4680 batteries using a new revolutionary dry battery electrode manufacturing process, Tesla has encountered several issues that they're currently working to solve. In past videos, I have briefly talked about some of these issues, but now thanks to new information that has been shared with me, I have a much better picture of some of the exact issues that Tesla is currently encountering and working through. Let's talk all about this. I'm John, and welcome to Cleanerwatt. First of all, I want to mention that the information that I'm sharing in this video comes from more than one source, and I'm going to not name those sources. And while the information that was shared with me appears to be credible, I've not been able to personally verify all of the information that I'm going to share with you in this video. So like with any new source of information, please use your own discretion and please verify all of the information for yourself before you take any actions based on this information. With that being said, before I dive into some of the specific issues that Tesla is having with the 4680 manufacturing process, I wanted to add a few quick follow-ups to my last video about the dry battery electrode process, starting with a quick correction and then a clarification. In the last video, when discussing the electrode film and foil lamination process, I mistakenly stated that the anode foil was traditionally aluminum and that the cathode foil was traditionally copper. I actually had those switched, as several of you have pointed out. So to clarify, the anode materials are laminated onto copper foil and the cathode materials are laminated onto aluminum foil. Secondly, when it comes to the lamination process that I described in the past video, according to one of my sources, Tesla's dry electrode manufacturing process doesn't actually create freestanding rolls of electrode polymer film as was described by the Maxwell Technologies white paper that I referenced in the past video. This may have been how Maxwell initially did it, but Tesla's new dry battery electrode manufacturing process was described to me as more of a continuous powder to lamination process. I will use the battery anode to provide a clear example of what the dry battery electrode process looks like. As it was explained to me, for the anode, this process starts with a huge, very long and very wide copper foil roll that already contains a super thin layer of carbon on the surface. The anode polymer powder mixture is fed through the feeding slot of a calendaring tool, which transforms the powder directly into its laminated film on foil state using heated rollers to evenly squash down the active anode polymer material and adhere it to the copper foil. Tesla's process does not actually involve manufacturing freestanding film that is then laminated to the foil in a separate process, as I previously thought. This joining process is what is referred to as lamination, and after this process you are left with large anode rolls which are ready to be cut down and formed into the anodes of individual 4680 battery jelly rolls. It's actually quite a fascinating process, but like with any new process, there are always issues and setbacks that arise that need to be solved. So let's talk about a few of these. As I've referenced in several recent videos, Elon's been giving some hints in recent investor conference calls as to some of the issues that Tesla is working through in their 4680 manufacturing process. For instance, in Tesla's Q2 2022 investors conference call, Elon Musk said, "Our focus right now is on the dozens of little issues that inhibit production ramp of the 4680. In this call, Elon Musk also said, "Some of the more challenging ones have been feeding the anode cathode material because we're using this revolutionary dry electrode process." So those comments from Elon Musk have given us some clues, but what are some of these specific issues that Elon Musk is referring to? Well, it was told to me from a source whom I was able to verify as credible that from what I assumed to be early on in the process, Tesla was encountering problems related to the fact that the equipment that they were using for the dry electrode manufacturing process was actually wider than any of the largest wet processing equipment that had ever been used in the past. Apparently, as another source mentioned to me, these dry process electrodes are formed into super long, and when I say super long, I mean double-digit kilometers long, and fairly wide rolls, somewhere around 2 meters wide. The specific issues that this width increase caused were not actually disclosed to me, but just with common sense, it's easy to understand that when you increase the size of a machine, issues that didn't show up in its smaller form are bound to pop up in the larger form. And once again, this is new equipment. I assume Tesla is past many of the issues caused by this size increase by now, and this reliable source did assure me that the dry battery electrode manufacturing process does work. So as Drew Baglino mentioned in Tesla's Q2 2021 investors conference call, referring to the reliability of mass-producing 4680 batteries, it's not a question of if, it's a question of when. Now moving to more current specific issues with the 4680 manufacturing processes, remember that Elon in the Q2 2022 conference call specifically mentioned that some of the more challenging ones, referring to the issues they are working to solve, have been feeding the anode cathode material because we're using this revolutionary dry electrode process. But just what problems is Tesla encountering with this feeding process? Well, according to one of my sources, one of the specific issues that Tesla has had to work through in the feeding process has to do with these electrode polymer powders clumping together. Remember that during the powder to film process, the powder is being fed through heated rollers to produce the electrode film that we discussed earlier. Apparently, if a clump develops in the electrode powder as it's being fed into the machine that forms it into the electrode film, these clumps can start collecting on the hot rollers that are used to laminate this powder. Eventually, these clumps can collect together and block the flow of electrode powder from entering the feeding slot of the calendaring tool. And sometimes these clumps can be nudged through without stopping the manufacturing process. But most of the time when these clogs form, the entire process must be shut down so the clog can be removed. The cleaning and removal process usually takes around 10 minutes, but it can take 30 minutes or more in some instances. The good news is that Tesla has apparently found several ways to greatly mitigate this problem. Before being fed through the electrode manufacturing equipment, the electrode powder polymer mix now goes through a process that creates pellets of compressed, compacted powder. Then through a jet milling process, this compressed powder is reprocessed into a fine powder once again. This powder is then refrigerated to below freezing temperatures before it is loaded into the roll-to-roll calendaring tool through a recently installed auto feeder. Tesla has found that if they store this electrode powder in this cold environment, once again below freezing, right up until the time that the powder is ready to be used, it keeps it nice and cold, and this helps eliminate the formation of these clumps. When it comes to just how successful Tesla has been at solving this clumping problem, according to my source, implementation of these processes has eliminated the vast majority of these clumping problems, and it was mentioned to me that this issue does still show up, but the solutions have drastically reduced their occurrence by around 98% or so, which means that Tesla has more uptime in their manufacturing process. Now, a second issue that Tesla is having with their 4680 manufacturing is actually related to the tabless design itself. As a reminder, instead of needing traditional battery tabs, which must be separately connected to the cathode and the anode, Tesla's tabless design involves laser cutting a series of what is referred to as flags into the exposed metal edge of the electrode material. As a reminder, that exposed edge does not have the active cathode or anode material adhered to it. These flags are then folded over on the terminal ends of the battery cells and take the place of traditional battery tabs when it comes to electrical connection. A normal battery design has 2 or more tabs which connect each electrode to the respective current collector, at least 1 tab connected to each battery electrode, for instance. Where Tesla's tablet design has somewhere around 1,000 flags or so that must be folded over to create the electrical connection with each respective current collector. Now, during the phase when the flags are being laser cut, Tesla's machinery uses controlled and directed puffs of air to fold over the flags in the proper direction. In addition, during the winding process of forming the battery cell jelly roll, these folded flags are further pushed down or reinforced with a ceramic finger that runs along the edge of these rolls. While this process generally works well, sometimes these flags can end up being bent the wrong direction and bend down into the center of the jelly roll. Any improperly folded flags can short circuit the cell and are either caught via an automated optic system and culled from the line, or the defect is discovered during high pot tests, which are carried out multiple times throughout the manufacturing process to weed out the bad cells before they get assembled into a battery pack. While the bad cells are detected at some point along the process and removed before they make it into battery packs, reducing the number of bad cells that have to be culled out in the first place is key for optimal efficiency, and this is what Tesla is working hard to reduce, and they appear to be having great success in their efforts. Now, when it comes to exactly how Tesla is working to solve this problem, with various changes including adjustments to the notching process and the winding process, Tesla has been able to greatly reduce the number of improperly folded tabs by somewhere around 90%, and thus has greatly increased the number of good cells that make it through the manufacturing process. This creates less scrap, which needs to be recycled, and increases the efficiency and output of their battery manufacturing. There's one last problem that I want to discuss, and that's what I want to refer to as telescoping. During the winding of the battery jelly roll layers, the three main layers in this jelly roll, the cathode, the separator, and the anode, they must be perfectly aligned. Any misalignment or telescoping of these layers can create a jelly roll that is too tall to fit in the battery can during assembly. When this misalignment occurs, Tesla's automatic systems will catch the misalignment, and that jelly roll will be culled and never make it to assembly. Most often, when this misalignment arises and is caught by the optic system, the offset is 1 millimeter or less, so these are some very precise optical devices and some very tight tolerances. In addition, rarely, but for similar reasons, an opposite misalignment can occur, which can lead to a jelly roll that is too short, and those jelly rolls are rejected as well. I don't know how often this telescoping occurs, nor what steps Tesla has taken to eliminate this from happening, but I have a feeling based on what I plan to share in my next video on this topic that this will be eliminated or at least greatly reduced in the new 3-in-1 machine that Tesla is currently developing. I'll talk more about that in the next video, so stay tuned. So really, to wrap all this up, in the end, you have to remember that the actual battery manufacturing operations at Giga Nevada are run by Tesla's partner, Panasonic. As a reminder, Tesla owns the building and Panasonic owns the battery manufacturing equipment. And this is the first time that Tesla has manufactured their own battery cells. As I have just discussed, Tesla is definitely making great progress with their revolutionary new 4680 battery manufacturing processes, and they definitely have made some impressive improvements to manufacturing reliability in a relatively short amount of time. I personally have a lot of confidence in Tesla's ability to further improve this process, and I believe that they're going to be successful with their 4680 manufacturing ramp in the coming near future. It's definitely going to be a fun journey. Do let me know what you think about all this in the comments section below. And also, if you work in the battery industry and you would like to share any insights or clarifications with me, feel free to email me. My email address is john@cleanerwatt.com. That's JON@cleanerwatt.com. Well, thank you so much for watching this video all the way through to the end. I'd like to take a moment to thank the Patreon supporters who support me every month and help make this content possible. A special thank you to my performance supporters and also the other supporters listed on the screen. If you'd like to find out more about the Patreon community I've set up, I'll put a link in the video description. Thank you so much.